In this video we're going to look at conditional probability, which can be somewhat tricky sometimes, but hopefully I give you a few tools that will help you make sense of it. To start, let's look at this orange problem. It says you pick a card from a deck of 52 cards. What's the probability you get the King of Hearts? So as long as you know that there are 52 cards in the deck and that only one of them is the King of Hearts, then you arrive at this answer, the probability that it's the King of Hearts. King and a heart, King of Hearts, is 1 out of 52. So no real computation, just a knowledge of a standard deck of cards and how many King of Hearts there are gives you that answer. This question is different, okay, this one in white, and it all centers on this word right here, or what distinguishes it from the one above is that word right there, given. So it says, what is the probability you get a king given that it is a heart? So to make sense of this, there's a nice visual tool that can help you kind of illustrate the situation when you're picking a card from a deck of cards, and that's called a Venn diagram. Okay, another tool is a tree diagram, which we've seen before, and I'll bring up again later. But a Venn diagram. So what a Venn diagram does is it just gives you a nice visual representation of all the possible probabilities and their outcomes. So what happens is you take that, it's often drawn inside of a rectangle there. That rectangle represents everything that can possibly happen in this situation. Right? All the possible outcomes when you're picking a card from a deck of 52 cards. And in our situation, we're concerned about hearts and kings. So I'm going to let this circle represent the probability of getting a heart. And I'm going to let this yellow ring represent the probability of getting a king. Now notice I'm going to overlap them. The reason I'm going to overlap them is because they need to share a common space, because you can pick a card that is both a king and a heart, and so that needs to be accounted for by this overlap here. But in general, that yellow circle is going to represent getting a king. And so now what we're going to do is we're going to fill in each section, because if you notice, this actually divides up the whole rectangle into 4 different sections. Right? You have all the stuff outside the circles. That whole region is one section. You have the stuff that's shared by both the orange and the pink, and then you have the stuff that's in I'd say orange. It's definitely like yellowish. In the yellow, but not the pink, and in the pink, but not the yellow. So we're going to go through one by one and assign probabilities to those events. So let's start with the simplest one. What's the probability of getting the King of Hearts? That we already saw is 1 out of 52. So I'm going to put that right in here, 1 out of 52. Now what's the probability of just getting a heart? The probability of just getting a heart, well, hopefully you know that there are 13 hearts in a standard deck of cards. So out of the 52, that means the probability of getting just a heart is 13 out of 52. But what I'm going to do is I'm not going to label the whole pink circle 13 because that's confusing. I already have a section of the pink circle labeled with the 1 out of 52. What I'm going to do is I'm going to put a 12 out of 52 in this region here. So what I'm saying is that in this pink but not yellow region right here that I'm just circling, right? That's all the hearts. That's getting a heart that's not a king, right? There are 12 hearts that aren't kings, so that probability is 12 out of 52. But now you can see that if you add up both those probabilities in the pink circle, you get 13 out of 52, which is what we want for hearts. The probability of getting a king is, well, there are 4 kings in the deck out of the 52. So I'm going to label this section here 3 out of 52, because this section means you got a king that wasn't a heart. But in the entire yellow circle, when you add those probabilities, you get your 4 out of 52. And so what does that mean about the space on the outside? The space on the outside means you get a card and it's not a king and it's not a heart. So one way to think about it is we've got 12 out of 52 plus 1 out of 52 plus 3 out of 52. That's 16 out of 52. And so if I do 52 out of 52 minus 16 out of 52, that leaves this having to be 36 out of 52. Because remember, when you sum up all the probabilities, it needs to sum up to 1. That's a important property of probability. Now this diagram helps us answer the question. very easily. What is the probability you get a king given that it is a heart? Well, first let's re-examine the first question we asked above. It said, what is the probability of getting a king of hearts? That you can just read off from by going to the correct section of our diagram. The king of hearts section is the one that's shared by both. That's a 1 out of 52. That gives us this answer without any work. Whenever you see the word given, you want to think of it as almost like information that's being revealed to you. And the effect of having information being revealed to you is that it shrinks your sample space, meaning it shrinks the amount of possibilities that can occur. So the probability that you get a king given that it is a heart, since we know it's a heart, my denominator now is completely centered on this circle right here, meaning this becomes the universe in this problem, because we know that we have a heart in our hands, right? You pick a card, and I tell you, the card in my hand is a heart. Now you ask yourself, what's the probability that it's a king? So let's do this first without any sort of the math jargon. You pick a card, I tell you it's a heart. Now you say, okay, it's a heart, so that means that it's one of those 13 heart cards that are actually in the deck, right? What's the probability that it's a king? Well, there's only one king of hearts, right? So that probability is going to be, the probability that it's a king given that it's a heart is going to be 1 out of 13. And I'm telling you it's a heart, so that means that I've narrowed it down to 13 possible cards. What's the probability it's a king? Well, how many kings are there in the heart suit? Just one. So that's one way to think about it. But we often want a more mathematical approach that'll help us in situations that aren't as familiar. And so that's where this idea of conditional probability comes in. The probability of getting a king given that it's a heart, by the way, is often labeled like this. Probability of king given heart. So this vertical line means given. Given. And a good way to view it is, it's the probability of getting a king and a heart. So it's the probability of getting the king of hearts divided by the probability of getting a heart. Okay, so this denominator is now the probability of getting a heart because we know that happened. The top is the probability of getting the king of hearts, the king and a heart. So this is a little different than the way we just thought about it in our thought experiment, because now we're sort of using probabilities to compute, not our sense of the amount of hearts in the deck. But this will work. Okay, so watch what happens. The probability of getting the king and a heart is 1 out of 52. The probability of getting a heart is, everything in that circle would be 13 out of 52. And what you see is that those 52s cancel, and you get 1 out of 13. 1 out of 13. Okay, so that's conditional probability. You're given information about what happened, and that has the effect of sort of shrinking the possibilities. This formula here is a commonly used formula, and again, the way I remember it is that the denominator is the given event, right? It's the probability of that given event because you know what happened, so that sort of accounts for your sample space. So more formally on the next page, I'll give you the actual definition of conditional probability. In 2 pages. All right, so here, if we're told that the event B depends on the event A, then the probability of B given A, which we often write as probability of B with a vertical line bar, A, is the probability of A and B divided by the probability of B. And visually, if you have your events A and B, it's the probability of this orange divided by the probability of what's in green. So orange divided by green.